Hi everyone! Today I'm going to show you how to solve a quadratic equation. First I'm going to solve a few examples by factoring, and then later I will use a few of the same examples by solving with the quadratic formula. First I want to show you graphically what it even means to solve a quadratic equation. So first of all, a quadratic equation comes in this form: y equals ax squared plus bx plus c. When you're solving for a quadratic equation, what this means is you're trying to figure out where does this equation cross, or where does this graph cross the x-axis on a plot. So here's x and y. The x-axis is right here. And this x-axis occurs where y equals 0. So when you're solving for a quadratic equation, you always must make it equal to 0. So it'd be 0 equals ax squared plus bx plus c. Then you're trying to solve for the value or values of x. And graphically what this means is you're trying to find these values. So in this case, you're only going to have one solution. In this case, you're going to have no solutions. In this one, you're going to have two solutions because there's two different x values where your graph crosses the x-axis, aka where it crosses y equals 0. In this one, you'll have two solutions. Same with here. And in this one, you're going to have one solution. And for all of these, the shape, this curved shape, is called a parabola. And that's always what a quadratic equation looks like when you put it on an xy graph. So let's jump into how do we factor a quadratic equation. The first example is 3x squared plus 18x plus 25 equals 0. In this example, a equals 3, b equals 18, and c equals 25. The first step is to multiply a times c. This equals 3 times 25, which is 75. And then we want to find two values that multiply to 75, but add to the value of b, this middle number. So it must add, or the two numbers must add to this value. Okay, so first one I'm going to try is 1 times 75. That adds to 76, so that doesn't work. 75 is not divisible by 2, so I'm going to move to 3. 3 times 25, that adds to 28, so these do not work. The next one is 4. That doesn't work. 75 divided by 4 is not a whole number, so we're going to move to 5. 5 times 15. Those two values add up to 18, so that works. So we're going to use 5 and 15 because they multiply to 75, but they add to 18. So now I'm going to rewrite the original equation. So we started with this, 3x squared plus 18x plus 25 equals 0. And now I'm going to rewrite this as 3x squared plus 5x plus 15x plus 25 equals 0. Next, I'm going to split this up into two chunks. So the first chunk is this blue section, which includes the first two quantities. And then the next chunk is these last two quantities. So let's look at the blue first. I'm going to divide each of these by a common factor. So we can pull out an x from each of those quantities. So x times 3x plus 5. Can't divide both of those quantities by anything else. So now for the green section, we can't divide those by x. We can't divide both of them by x, but we can divide both of them by 5. So I'm going to pull out a 5, and we're left with 3x plus 5 equals 0. Notice how these two quantities are the same, and so we can pull those out, and we're left with 3x plus 5 times x plus 5 equals 0. Okay, so we started with this equation. That is equivalent to this equation. It's just now we have this in factored form. Now the last step is to solve for x. So in order to solve for x, this quantity must equal 0 in order for 0 to equal 0, or this quantity can equal 0. So in order to do that, we're going to split this up into two sections. So 3x plus 5 can equal 0, or x plus 5 can equal 0. And now let's solve for x. So this one, we have 3x equals -5, x equals -5 divided by 3. And then this one over here, we have x equals -5. So those are our two answers, or our two solutions. This one is the same as -1.67-ish. So if we want to look at this on a graph, it would look something like this. 1, 2, 3, 4. -5. So we have a point right here, and we have a point right around here. This is x, y. And then that parabola is going to look something like that, where we have one value at -5, 0, and then another value at -1.60. The next example is 2x squared minus 13x plus 21 equals 0. In this example, a equals 2, b equals -13, c equals 21. And just like last time, we're going to multiply a times c. So 2 times 21 equals 42. And then we're going to find two values that multiply to 42, but add to this, b. So I always start with 1 just to make it simple. So 1 times 42, that adds up to 43. So notice how this adds to a positive number, but we need it to add to -13. So we're going to need to use negative numbers instead. So -1 times -42, those add to -43. That does not work. So -2 times -21, that adds to, -23. That doesn't work. -3 times -14. If we take those two values and add them together, we get -17. Doesn't work. We can't divide 42 by 4 and get a whole number, so that doesn't work. 5 doesn't work, so then let's try 6. 6 times -7 equals 42, and -6 plus -7 equals -13. So this works, so we want to use this combination. So once again, I'm going to rewrite the equation, and then I'm going to write it differently, where I separate out -13 into -6 and -7. So I'm going to rewrite this as -2x minus 6x minus 7x plus 21 equals 0. And just like last time, I'm going to split this up into two chunks. This first chunk includes those first two quantities, and the second chunk includes these last two quantities. So let's look at the blue chunk first. We want to find something that we can pull out of each quantity. So we can take out a 2x from both of those quantities, and we'll be left with x minus 3. And then let's look at the green chunk. The most that we can pull out of both of those quantities is -7. So we'll pull out -7, and we're left with x minus 3, and that equals 0. And the goal when we do this is to have the same factor right here in each of these chunks. So x minus 3 is in both of them. So in this next step, we can pull that out. So we'll get x minus 3 times 2x minus 7 equals 0. And now we want to solve for x. So in order to solve for x, we have two possibilities that would make this whole thing equal 0. So either this chunk right here would equal 0, or this chunk right here would equal 0. So we're going to look at both. So we'll have x minus 3 equal to 0, and 2x minus 7 equal to 0. And then we'll solve for x. So this first one, we're just left with x equals 3. And then for the second one, we have 2x equals 7, and x equals 7 divided by 2, which is the same as 3.5. So our solutions for this quadratic equation are x equals 3 and x equals 3.5. And what this looks like graphically is this parabola will cross the x-axis, which is the same as the line y equals 0, at x equals 3 and at x equals 3.5. And since this quadratic equation started, like when this whole thing was set equal to 0, it started with a positive coefficient in front of the x squared, which means that this parabola is going to be pointing upwards. And so it's going to look something like this. The next example is negative 4x squared plus 6x equals 2. Notice how in this one, the entire equation is not equal to 0 right now. And like I said in the beginning, before we move forward, we have to set the whole equation equal to 0 first. So to do that, I'm going to subtract 2 from both sides, and we're left with negative 4x squared plus 6x minus 2 equals 0. Before I move on to the next steps, I want to explain what this actually means graphically. So what this is we're looking at the equation y equals negative 4x squared plus 6x minus 2, and then we're just setting y equal to 0 and solving for x because we're trying to figure out where this parabola crosses the x-axis. And the x-axis occurs where y equals 0. And so this might look something like this. And we know that it points downwards because the coefficient in front of x squared is negative. Therefore, the parabola must point down. Okay, so now let's move on to what we've done in the previous examples. So again, we're working with negative 4x squared plus 6x minus 2 equals 0, and we're trying to solve for x by factoring. Before anything else, let's try to simplify this to make it easier on ourselves. So let's see if we can pull out any number or variable from every quantity in this equation. It looks like all we can do is pull out a negative 2, and so if we take that out, we're left with 2x squared minus 3x plus 1 equals 0. Then I'm going to divide both sides by 2, or by negative 2, and we're left with 2x squared minus 3x plus 1 equals 0, because 0 divided by anything is 0. Now let's do what we have done for the previous examples. So a equals 2, b equals negative 3, c equals 1, and then we want to multiply a times c. So 2 times 1 equals 2. We want to find two numbers that multiply to 2 and add to negative 3, which is b. So I would start with 1 times 2. Those values add up to positive 3. We need them to add to negative 3, so now I'm going to try out the negative values. So negative 1 times negative 2 equals 2. But when you add those values together, we get negative 3. So that works. So we're going to go with those two quantities. And then I'm going to write out the equation again. And I'm going to switch out negative 3x with negative x and negative 2x. So 2x squared minus 1x minus 2x plus 1 equals 0. And then just like before, I'm splitting this up into two chunks. The first chunk includes those first two quantities. The second chunk includes the last two quantities. And then I'm going to look at the blue chunk first and see what I can pull out from both quantities. So I can pull out an x, and I'm left with 2x minus 1. And then for the green chunk, I can pull out a negative 1, and I'm left with 2x minus 1, and that equals 0. And again, the goal is to be left with these factors equaling each other. So then we can pull out that factor from both chunks, and we're left with 2x minus 1 times x minus 1 equals 0. And then we're trying to solve for x. So in order to do that, this first quantity, 2x minus 1, can equal 0, or the second quantity, x minus 1 equals 0. So this is 2x equals 1, and x equals 1/2, and then this is x equals 1. So our solutions are x equals 1/2 and x equals 1. And then on a graph, what this looks like is our original equation crosses the x-axis at x equals 1 and at x equals 1/2. And just like I explained before, the original equation, when you set it equal to 0, looked like this. And the coefficient in front of x squared is negative. Therefore, this parabola is going downwards. So it's going to look something like that. This next example, we're going to solve for x squared minus 4x minus 12 equals 0. First, I'm going to go through the longer method, which is what we've done for the previous problems, and then I'm going to show you a shortcut for this kind of problem where we have a 1 in front of the x squared term. So, just like before, a equals 1, b equals -4, c equals -12. And then we're going to multiply a times c. So that's 1 times -12 equals -12. And we want to find two values that multiply to -12, but then add to -4, which is b. So we can do 1 times -12. When you add those up, we get -11. That does not work. 2 times -6. When you add those up, we get -4, and that works. So let's use those two values. So just like we've done in the previous problems, I'm going to rewrite this as x squared plus 2x minus 6x minus 12 equals 0. And then I'm going to split this up into two chunks. And then for this blue chunk, we can pull out x, and we're left with x plus 2. And then for the green chunk, we can pull out -6. And again, we're left with x plus 2. And then we can factor out x plus 2. And we're left with x minus 6. And then just like before, we can set this factor equal to 0 as well as this one and solve for x. So this first one is x minus 2. The next one is x equals 6. So those are our solutions. Notice how up here, those are found right here and right here. So I'm going to show you a shortcut for this kind of problem where we have 1 out front. So I'm going to do this problem again, but with the shortcut. So we're starting with x squared minus 4x minus 12 equals 0. And then we notice that we have a 1 out front. And so we can do 1 times negative 12 equals negative 12. And then we're going to find two values that multiply to negative 12 but add to this. So we're starting off the same. And again, just like before, we found out that 2 times negative 6 works. But this time we can just jump straight to factoring. And so this is going to be x plus 2 times x minus 6 equals 0. And then from there, x plus 2 equals 0, x minus 6 equals 0, and then x equals negative 2, x equals 6 are our solutions. So again, that's the shortcut method where you can jump straight to factoring. And then on a graph, what this would look like is this equation would, when you graph it, it would cross the x-axis at x equals negative 2 and at x equals 1, 2, 3, 4, 5, 6. And then if we look at the original equation, it's positive 1 in front of the x squared, so we know it's going up. So this parabola would look something like this. The final example for this video is negative x squared plus 2x plus 3 equals 0. So before I jump into solving for x, I want to explain what this means graphically. So this is the quadratic equation for this is y equals negative x squared plus 2x plus 3. And then when we're asked to solve for this quadratic equation, we're just trying to find the x values of where this graph crosses the x-axis. And so since we have a negative 1 in front of the x squared term, we know that this parabola is going to look something like this, where it's pointed downward. Okay, so now let's jump into solving this quadratic equation. So the first step is to always look for ways that we can simplify the equation. And it's always easier to have a positive number in front of the x squared term when we're solving for it. So I'm going to divide both sides by negative 1. This leaves us with x squared minus 2x minus 3 equals 0. Once again, because 0 divided by anything is just 0. And now, since we have a 1 in front of the x squared term, we can use the shortcut. So the shortcut, again, is just, once again, you multiply your a term times your c term, and that gives you negative 3. And then we're trying to find two values that multiply to negative 3 and add to negative 2. So add to the b coefficient. So we could do 1 and negative 3, or negative 1 and 3. Those are our options. And then this one adds to negative 2, this one adds to positive 2, so this is the combination we want to use. And so since we have the special case where we have a positive 1 in our a coefficient, we can jump straight to factoring. So I can rewrite this equation in factored form as x plus 1 times x minus 3 equals 0. And then we just solve for x. So this one will give us x plus 1 equals 0. This one will give us x minus 3 equals 0. And then that gives us x equals negative 1 and x equals 3 as our solutions. And then on a graph, what this looks like is the graph, the original quadratic equation, when graphed, is going to cross the x-axis at negative 1 and at x equals positive 3. And like I said before, this was the original equation, and since we have a negative in front of the x squared term, this parabola is going to be pointing down like that. For the last part of this video, I'm going to show you how to solve two of the previous examples using the quadratic formula. So first, as a recap, this right here is the standard form of a quadratic equation. So it's ax squared plus bx plus c equals 0. And the quadratic formula is just a way to solve for x, where you plug in the a, b, and c coefficients into this formula. So let's start off with one of the examples that I showed before, which was 2x squared minus 13x plus 21 equals 0. In this example, a equals 2, b equals negative 13, c equals 21. And then all we're going to do is plug it into the quadratic formula. So x equals negative b, so negative of negative 13, plus or minus the square root of negative 13 squared minus 4 times a, which is 2, times c, which is 21, divided by 2 times a, so 2 times 2. And then I'm going to whip out a calculator, and I'm going to plug these in. So up front, we're going to have positive 13 plus or minus the square root of negative 13 times negative 13 is 169, minus 4 times 2 times 21 is 168. That's divided by 4. So x equals 13 plus or minus the square root of 1 divided by 4. The square root of 1 is just 1. So we have 13 plus 1 divided by 4, and x equals 13 minus 1 divided by 4. So this first one is 14 divided by 4, and the second one is 12 divided by 4. So that's just 3, and this one, 14 divided by 4, is 3.5. So those are the same answers that we got before. It's just a different way to solve. And then the second example from before that I'm going to use is negative x squared plus 2x plus 3 equals 0. So again, a equals negative 1, b equals 2, c equals 3, and then we're going to plug it into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, and divide that by 2 times a. So we're going to plug it in. X equals negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times 3 divided by 2 times negative 1. So I'm going to simplify this. X equals negative 2 plus or minus the square root of 4, and then this is plus 12. And that's divided by negative 2. Simplify it further. X equals negative 2 plus or minus the square root of 16 divided by negative 2. Square root of the square root of 16 is 4. So this is x equals negative 2 plus 4 divided by negative 2, and x equals negative 2 minus 4 divided by negative 2. And we'll simplify that further. This is 2 divided by negative 2, so x equals negative 1, and x equals negative 6 divided by negative 2, so x equals positive 3. And those are your two solutions.